Okay, we are in chapter 3, which is all about graphs. Okay, so we're going to graph coordinates on a plane. It says in 17th century, that's like the 1600s. Okay, Rene Descartes, a French mathematician, philosopher, used a horizontal and a vertical number line to divide a plane into 4 regions called quadrants. Quad means 4 in Latin. Okay. It says a plane set up according to Descartes' system is also known as a Cartesian coordinate plane. Okay, so this guy, Rene, he was French, and he noticed, supposedly the legend goes, is that he saw this fly on his ceiling. And the ceilings were in tiles like this, and he thought, okay, if the fly were to land right here, how could I say where this fly is in location? And so he said I could say it was this many numbers this way and this many numbers this way. So he took a number line, flipped it, and created a coordinate plane. And that supposedly is how he came about it. He called this quadrant 1, this quadrant 2, quadrant 3, and quadrant 4. He went counterclockwise. Clockwise is how the clock would go. Counterclockwise is the opposite. Okay. And it was called Cartesian because his last name was Descartes. So it kind of played off of his name. And it's a coordinate plane because you can put coordinates in here. Okay. The horizontal line, like think of the horizon, the sun, is the x-axis. Okay. And numbers on this axis are called x coordinates. The vertical line is called the y-axis, and the numbers on this axis are called y-coordinates. It says the ordered pair 0, 0, which is right here, is called the origin. So if you were to graph the coordinate 2, 4, we know that this is x and that this is y. So we have to go to the x-axis at 2, and then the y-axis is at 4. So you go over to 2 and then over to 4 and you make a dot. Okay, and then they want -1, 3. So you go over to -1 on the x-axis and 3 on the y and place your next coordinate. -3, so you go to the left and then you go down 5 because it's negative. And you make your coordinate there. And lastly, we have 4, -2. So that's where your coordinates should be. Some of this will be familiar to some of you, and some of you it won't be familiar. So that's why we're starting at chapter 3. If you're 100% virtual, all of you are starting at chapter 3 to make sure that we understand this. Okay. Look at the coordinate plane and determine the coordinates for the following points. So now we're saying, okay, I on the x-axis went over to 3 and I went up 2. So for A, it's 3, 2. For B, start at the origin. We went to the left -3 and down 5. Okay, for part C, we went to the left 2 and we went up. Oh, I'm sorry, we're over here. We went to the left 1 and up 3. And for part D, it's 6, 0. Okay. That's it. So that's how you graph them, and that's how you find their coordinates if they're already graphed. The next page says, where do these coordinates come from? Most of the time, ordered pairs are extracted from equations. Look at the expression 2x plus 1. What is the answer when x is negative 1, 0, and 1? Hello? Yes. Recording a video. Give me like 10 minutes, 5 minutes. Okay, bye. Sorry for interrupting. I had to answer the phone, but I'm not stopped recording because we're partially through the video. Okay. It says, where do these coordinates come from? Most of the time, ordered pairs are extracted from equations. Look at this expression. What is the answer when x equals negative 1, 0, or 1? So if I substitute in negative 1, what do I get? 2 times a negative 1 is negative 2, plus 1 is negative 1. Here, when I substitute in 0, I'm going to get 1. And when I substitute in 1, I'm going to get 3. Okay? So this is where the coordinate comes from. The coordinate would be negative 1, 0, 1, and 1, 3 because it went through some kind of process, which is our equation, our expression. X is called our domain or our input. And it is our independent variable. We got to choose. We got to choose what values go in there. And then our answer is our y, or our range, or output, or dependent variable, because it was dependent on what x was. It says these output values are also called y. Therefore, we can write our expression as this expression is equal to y, our output. It says make a table for the equation y equals 3x minus 1. So we have our input, we have our output, and then we have our process in between. Graph the ordered pairs in the coordinate plane and connect the points to make a line. A linear pattern is said to exist when the points make a straight line. So they want us to use here, it says negative 2, negative 1, 0, 1, 2, and 3. So go ahead, pause, and put all the numbers in just like this. I want you to pause, find the outputs, and then graph them. Okay, so here are the coordinates. I want you to pause and make sure you have them and you write down the right process. Okay, normally it's just an X and a Y. You'd have to write this on a separate sheet of paper. So our coordinate is negative 2, negative 7. Then it's negative 1, negative 4. Now it should be in a straight line. 0, negative 1, 1, 2, 2, 5, 3, 8. Okay, yeah, it is in a straight line. Okay, so that's how you're going to graph an expression. You put in some numbers, you get some answers. So on the next page, when they want you to graph these, okay, they're giving you values. If I need 3x minus 2, sorry, you're going to have to, off to the side, do the work. Okay, that's going to be 7. When I put in a 2, that's going to be 5. When I put in a negative 2, oops, it's actually supposed to be 4. When I put in a negative 2, it's going to be negative 6 minus 2, which is negative 8. When I put in a 0, I'm going to get negative 2. So this needs to be proper, a straight line. If I go to 3, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. Okay, when I put in a 2, 1, 2, I should get 4. 1, 2, 3, 4. When I put in a negative 2, I should get a negative 8. 1, 2, and I go 1, 2, 3, 4, 5, 6, 7, 8. 8 and a 0, I should get negative 2. Okay, yeah, it worked. Now, what letter does it cross out? T. So I'm going to go over to T, and where there's number 1, I'm going to write a T. Okay, I want you to do this for the whole sheet. I'm going to go over the next answers in our next video, which is part 2 of your lesson.